Greetings, everyone, from my hometown of Chicago, Illinois, where I'm spending some much needed time with family and friends as we head into fall. I'm excited to bring you this month's Math Fix task, so without further ado, let's get started.
Today's Math Fix is brought to you by G.SRT.8, which asks students to use trigonometric ratios and the Pythagorean theorem to solve right triangles in applied problems. Let's take a look at our problem today. Students are asked to make a recommendation to a convenience store manager on where to place a security camera in order to be sure to see the faces of every customer that enters the store. Where might students start with this? Let's jump in. Students might initially struggle with the setup of the problem being so open-ended. You might suggest to them that they sketch a side view of the store and think about the height of the ceiling, where the entrance might be in reference to where the camera might be installed, and the average height of a customer to ensure the camera captures their faces. One example could be the one outlined in the curriculum, where the camera is mounted 15 feet from the entrance at a height of 8 feet off the ground. Students may come up with a range of numbers here based on their own assumptions. Where the problem gets interesting is in thinking about the angle of depression at which to mount the camera. Assuming most customers that come into the store alone will be teenagers or young adults, it might be reasonable to assume a height of between 4.5 and 6.5 feet. In the case where the camera is mounted 8 feet off of the ground, then, we would want to capture images from 1.5 to 3.5 feet below the camera. We might choose to aim the camera so that it points to a location 2.5 feet below its mount height, assuming it will capture images above and below. In this case, and with these assumptions then, we can calculate the angle of depression using the arctangent of 2.5 over 15, which gives us approximately 10 degrees. Of course, there are many variations on this theme depending on students' initial assumptions about the setup of the problem. One possible extension to this problem might be to have students think about a rotating camera in an oblong shaped store, such as the one in this diagram, and where to position the camera in order to maximize the area of the store seen.
And that's this month's Math Fix task. We know there are lots of different ways that you can adapt this problem for your students, and we look forward to hearing about those ways. Don't hesitate to share with us your take on our October Math Fix problem. Until next time.